Welcome to another video on heat transfer. So this one we're gonna go ahead and solve one of the exercise problems, right? And it's taken from the same book, okay? Now let's read the question. They're saying that there's an infiltration of cold air into a warm house during winter, and they're saying that infiltration is in terms of ACH. And so they give a description of what ACH means, right? And then they're saying that so electrically heated house, floor space of this much, height of this much, at this elevation, and they're saying atmospheric pressure is that. And so just some important information that we have to know in order to solve the question. So let's go ahead and write all this information as much as we know, okay? So what I do is I draw, right? I draw a house because it helps me get a visual representation of the problem, okay? So this is the house that we're concerned with. And they're saying that this house temperature is maintained at 22 degrees Celsius. So let's go ahead and say this is 22 degrees Celsius. And the outside air is 5 degrees Celsius. So outside is 5 degrees Celsius. Now, what do we know about this house? So the floor is 200 meter square, and the height is 3 meter, okay? This gives us a volume of the house, which is 600 meter cube. And the pressure is held constant because they say that assuming the pressure and temperature remains constant, okay? So pressure is 89.6 kPa. What else do we know? So we have that. We have an ACH 0.7, okay? And that's it. That's all the information that we have. And this is enough, okay? Now we have to find the amount of energy loss due to infiltration for a day, okay? This is important for a day. Now we have to find how much air would be replaced in 24 hours. So if 0.7, so the example that they gave is air exchange per hour, right? If ACH equals 2, it means in 1 hour the air is replaced twice, right? So twice. It means, say, we find that, for example, okay, let's say we have a certain amount of Q dot is, I don't know, like 3 watt. That much heat transfer occurs. That's just one time, okay? That is just one time. And if we have an ACH of 2, it means in 1 hour, you get the idea, right? So if only 0.7 air is being replaced in 1 hour, then for 24 hours, right, how much air is getting replaced? So this is air replaced, okay, or air exchanged. Then we find that in 24 hours we have 16.8 times air is replaced or exchanged. So in one day, the air that enters this house, right, is replaced 16.8 times. So you will see why that isn't important in this problem, okay? So that's what we have, okay? Now it just means that the energy loss is basically an enthalpy change of the house, because they're saying that the air is like the cold air infiltrates through the cracks, right? So just an enthalpy change, and the formula for enthalpy is delta H equals mCp of average and then delta T. Okay. Now we have to find how much air is getting into the house, and we already know, like, let's just use this formula. Okay, PV equals m or T, a very classic formula. So from this formula, we know P, we know V, we know R, we know T. We just have to find M and replace that M here. Okay, so M equals PV RT, and PV is given at 9.6, right, times 600 times R is 0.287, and then temperature. Now, what temperature do we write here, right? This is very important because it changes the answer completely. We can either write 5 or we can either write 22. But the question says that some air is getting into the system, right? And the property, this is for the air that is here, right? There's here, that air. And the volume is that air getting into the space, okay? And this is also a property of the air. Now, this means that we are basically considering the amount of mass that enters the house, which means the mass that is here, right? The mass that is here, and this mass enters the house, but before it enters, it's at 5 degrees Celsius. Okay, that's very important. So what we're gonna do, we're taking 5 degrees Celsius, and if we convert that to Kelvin, that's just 273 plus 5, which is 278. Okay, and so now once we know that, we can just find M, which is 673 kilogram, and we find that in one day the whole air exchanges 16.8 times. So it just means that if in 1 hour, right, if at one exchange 673 kilogram enters the house, then at 16.8 exchange, just a multiplication, right? At 16.8 exchange, so 673 times 16.8, 11,306 kilogram per day, okay, enters. That's it. So that much mass enters the system in a day. Okay, so once we have that, we can replace this value with this. We have to find Cp, and we know T. Okay, what is Cp? So we just have to look at the table, and from the table of air properties, for Cp, we have a value of 1.007 kilojoule per kilogram C. So that's the value that we have for Cp. Now we just plug in the data, right? Energy loss, which is just that, and that is 7, and the difference in temperature, which is 22 minus 5, and that gives us a total energy loss of 'So that's our total energy loss, okay, in one day. I should specify in one day. Now the second part asks that we have to find how much does this energy loss cost us, and so that just means that we have to convert this final answer to kilowatt hour, because they gave us a rate of 0.082, right, dollar per kilowatt hour. Okay, so that's the rate that they have. And to convert from kilojoule per day to kilowatt hour, we just have to divide this value with 3600. So that would be 193,547 divided by 3600 gives us a value of 53.76 kilowatt hour. So that's the value, okay, per day. That's how much it is in kilowatt hour. Now we just have to multiply this with this, and that will give us the final answer. So total cost in 1 day is 53.76 times 0.082, and that gives us a value of $4.408 or $4.41. And that's our final answer. And if we check the solution that they gave us, this is exactly it. Thank you for watching, and write down any suggestions if you have any. Thank you.